In today's era of microservices and distributed systems, containerization has revolutionized how applications are built and deployed. One such tool is Docker. Docker is a leading containerization platform which not only helps in packaging applications, but also provides a robust networking features that allows containers to communicate with each other. In today's job scenario, every company is asking you to learn Docker. So for the same, we have covered Docker networking tutorial in today's video. Before we move on, just a quick info guys. If you want to become a DevOps expert, then you can join Simplilearn's course, which is in collaboration with IBM. In this DevOps Engineer Certification course, which is developed in collaboration with IBM, will help you refine your skills. In this course, you're going to learn about Docker, Kubernetes, Ansible, Terraform, Prometheus, Jenkins, Microsoft, and Azure DevOps methodologies. So guys, hurry up now and join the course. The course link is mentioned in the description box. So let's get started. So guys, I have opened official documentation of Docker and we are going to learn about networking. So you would be wondering why Docker networking? So guys, basically Docker networking allows containers to communicate securely and efficiently both with each other and also with the outside world. Networking is a very critical part of containerized applications because in most of the real world cases, applications are not isolated. They need to talk to databases, APIs, microservices, and also external clients. In traditional environments, if I talk about, networking setup and management can be cumbersome or a little bit complex, in which you would be required a complex configuration of firewalls, subnets, NATs, which is Network Address Translation Protocol. But Docker abstracts much of this complexity, providing out-of-the-box networking solutions, which I will show you in today's hands-on tutorial. Now, let us consider one example. So, to suppose, in this typical scenario, you can see the front end is communicating with a backend API. And the backend, you can presume that it is also communicating with some database. Okay, so this is our database. When these services are containerized, so suppose you can see all over here, the front end part is containerized all over here and back end part is put into the container all over here. Now they are communicating internally. So with the help of Docker networking, you can connect these containers in an isolated environment where front end container sends requests to the back end container, which then queries the database. Okay, so with the help of Docker networking, this communication is possible. And we are removing any complex manual network configuration that is needed. So let us see. So suppose we have the front end container, we have the back end container, here is our Docker, and suppose we are using EC2 instance as a host. Now, let us try to understand first what is the difference between Docker and VM networking. Now guys, if I talk about Docker versus virtual machine. So in a virtual machine based environment, each virtual machine typically runs an entire operating system and it has its own dedicated virtual network interface. Okay, these interfaces must be connected to a physical or a virtual switch, and which the underlying technology is a hypervisor. So configuring virtual networking involves setting up IP addresses, subnets, routing rules, and firewalls. For example, if you want to connect two virtual machines, one running a backend service and another running a database. To communicate with each other, you need to assign static IP addresses, configure network routes, and ensure that the firewall rules allow traffic between them. Such of a manual task we have to do. And additionally, if external clients also need to connect to the backend, more routing and firewall configurations are required, which makes this process so complex. But if we talk about Docker networking, then Docker saves us. Docker networking is more lightweight, flexible, and efficient. When you run a container, Docker provides a virtual network interface, or you can say a virtual Ethernet. Okay. Now, this VEth or virtual Ethernet and containers can be connected to Docker's virtual network bridges or custom networks, which we are going to learn a little bit later. In Docker, you don't have to worry about manually configuring subnets, routing, or NAT. Docker automatically handles most of the networking setup for you. With Docker's built-in network, such as default bridge network or user-defined network, containers can communicate with each other very seamlessly. Now, you'll be wondering, how do containers communicate with each other in terms of networking? So let us see this example. So you can see all over here. Suppose we have an application container all over here, and the IP address for this is something like 172.18.0.12. Now, when you initialize the container, the Docker also gives it the IP address, which is the virtual Ethernet network or virtual network, and which we generally called it as Docker 0. Okay. Now, similarly, the host, where you can say it is an EC2 instance, okay, with 192.16.0.12. Okay. Now, just forget it for a moment. Okay, we'll not consider this. So, when app is directly trying to communicate with the host, okay, so nothing is involved. Let me remove this. Now, so in this application, you can see all over here, the IP address for this is 172.18.0.12, and the host with echo, so Docker has given this a network of 192.16.0.2. Now, when this is trying to communicate with each other, I ask you one question. You can pause this video. Will they be able to communicate with each other? So guys, the answer for the same is no, not at all. There's going to be a network error because they are belonging to different subnets. Now, if I talk about how this problem resolves by Docker, so Docker does what, guys? Docker provides a virtual Ethernet, which is called Docker 0, all over here, and which makes a network configuration. The default one is bridge network, okay? Now, both of them can easily communicate with each other. So say one good example, I want to take it with this. So say you have a login container, you have the payment container, okay? Now, say both of them have a default network configuration in which, say, bridge network configuration. Don't worry about it, we will learn the different type of network configuration. So we are presuming that this network configuration is a bridge network. Okay. Now say login container is a kind of a user-based container where you have to log in through your email, ID, and password. And similarly, you have a more crucial, or you can say more important part of this application is a payment container, which is very, very important. Okay. Now, what you do in order to communicate, so I told you earlier, so Docker does what? Docker creates a virtual Ethernet connection, okay? And this is Docker 0, okay? Now, say we are using the same path, okay? The same payment C with this container, payment container, is trying to communicate with the host through this, okay? Through this Docker 0 network. Now, both of them are trying to communicate with each other. Now, in the payment container, say in this application where user types its credit card number and a lot of other payment details, so hackers can easily exploit it because they are not at all secure, first of all, and they are trying to communicate through the same path, so a hacker can come up and steal some important secrets and data that can be vulnerable for your application. Now, in order to secure this application, guys, we have another scenario. What we do, basically, we need to isolate this from this container. Now, the solution for this is creating your own custom bridge network, okay? So that the IP address for this and IP address for this do not belong to the same category, okay? So this needs to be isolated from each other. So let me show you one more example. So this is a proposed solution in order to do the same. So what we do, basically, so in order for connecting at this network, what do we do? Basically, we are creating our own custom network. That's one of the important features of Docker, which we'll be doing in our today's tutorial also. So now the path is not same. So hackers cannot come and steal your important credentials or data. Now, this is one of the very basic, you can say configuration all over here. Now, this is our next configuration. So this architecture we'll be doing in our today's tutorial. So imagine we have these two containers, login and product, okay? And they are pretty much communicating with each other over the same network, which is Docker 0, okay? So Docker has provided the virtual network for it, and we generally call it by Docker 0. And it is communicating with the host, okay, with the echo of 1.172.16.1.2. Now, the payment process is very, very, I would say, very critical part of the application where you need to or prevent its, you need to keep it isolated. You don't want any of the containers to communicate with this. Now, what you do basically all over here, that you create your custom virtual bridge network which communicates with the host directly. So this payment container is completely isolated from this container. So in this way, you are making this container isolated, and also you are making your application secure. And this is what is the beauty of Docker. Now, what we are going to do all over here, the next part which I want to tell you about the type of network. Since I have discussed you regarding the bridge networking, so let me tell you what exactly a bridge networking is. So say there are three types of networking. Okay, the first one that we have all over here is bridge networking. So Docker creates a virtual network interface on the host with a typical name of Docker 0, as I told you earlier. This virtual bridge connects all the container on the default or user-defined bridge network, which allows them to communicate with each other with the host. And typically, all the containers receive the internal IP addresses from a certain private subnet range, basically, which can be 172.xxx. Okay. So bridge networking is a special type of networking. It's a very default networking, which even if you don't define it, Docker is going to define it for you. And here, your network interface or virtual network interface, you're going to get Docker 0 all over here. That's a basic thing. And bridge connects all the container. Okay, so important part all over here is with the help of bridge. So it connects all the container. Now, how bridge networks work? So let us take this example, what we have all over here. So you can see this is an app container. Okay, say the IP address for this is 172.18.0.12, which is assigned by the Docker. Okay, now this cannot communicate with each other, as I've already told you. So this application container, in order to say our host is an EC2 instance, now in order to communicate this app with this host, you need a bridge network. So that's why here Docker 0 is our bridge network, which is trying to communicate, because they are belonging to different subnets. Okay, they cannot communicate. So for the same purpose, Docker gives us the bridge network. So now, with the help of NAT or Network Address Translation Protocol, these containers can communicate with each other. So this is how our bridge network is working. But the thing with the bridge network is all the containers can communicate with each other. So in this scenario, if I tell you what kind of network they all have, so they are all sharing the bridge network configuration, so that this login container and the product container in a given microservice are easily able to communicate with each other. So Docker 0 is our bridge network, and here you are interacting with the host. Now, if I talk about some of the security concerns with respect to the bridge network, so login and product, they all have shared network. Okay, so all the containers connected to the same bridge network can communicate with each other. But if one of the container is compromised, it could potentially target the other containers also on the same network. So unless additional network policies or firewall rules you have given, this can be a little bit problematic. The second scenario that I can see is access to the host port. So if port forwarding is used to expose the container services, then attackers can potentially target the host machine through the misconfigured or open ports. So these are some of the security concerns with respect to this. Now let us discuss about the host networking. In the host networking, the container bypasses Docker's virtual network interface and shares host machine's network stack. It means that the container does not get its own internal IP address. Instead, it uses the host IP address and the network interfaces directly. This setup is basically useful for applications that require high network performance, low latency, and also a direct access to the network resources. But this is also very, you can say, security concerning. So here, all of them will be communicating through the same network. And the problem which I told you earlier, the attackers can easily come in and steal your important data. So instead of assigning the internal IP address from a private subnet, container directly reaches via host IP address. For example, in this scenario, say our host has an IP address of 192.16.0, okay, and a container is running with the host networking will be somewhat around 198.61.1.100. So here your IP address is going to change. So if I talk about the IP address for this, it will be using the host IP address. And they all will be communicating with the same network, okay? And which can be a little bit problematic. The security concerns will be more. And the container can use the same network interfaces, ports, and network routing as the host is using. Okay, so you are not assigning any private IP address to this container if you are using the host networking. So in this configuration, we can see there is no network isolation is there. Okay, port conflicts can also happen, like container running with the host networking share the same network namespace as the host. And this means basically that if a container tries to use the port that is already in use by a service, say it is using a port 80 or for a web server, then there will be conflict. So you need to follow careful planning, okay, to avoid these kind of conflicts. Then no NAT is happening all over here. So host networking is not using network address translation protocol. Containers are exposed directly to the host network interfaces, and it reduces the security in this scenario. So for these reasons, host networking is typically not recommended to use in production environments unless or absolutely necessary for performance-based reasons. So I hope so you would have got some idea regarding host networking configuration. Now let us move ahead and try to do the hands-on based on this architecture. So I'll be using a local repo, and in that I will be creating the container for login, product, and I will be assigning them the bridge network. And then I'll be creating my own custom bridge network, okay, so that this security concern does not happen, because if it is using the same, as I've told you earlier, same network of Docker 0, then the attackers can exploit this and steal away your important credentials, which we don't want to happen in our application. So we are creating a custom bridge network, and this will be all happening in our terminal. So let us start our Docker engine and directly deep dive into it. So in our hands-on video, what we'll be going, so we'll be using the same architecture that we have discussed, which is this one. So we are going to create a login container, a product container, and connect them with the bridge network. Then we are going to create a payment container and with a virtual bridge network. And we'll be using the ping command to check from where the communication is happening, which is reachable and which is not. So it's a pretty basic tutorial. Please follow me along. And if you have any doubt, you can pause the video and go back. So container 1 is our login container. This is our product container, and this is our payment. So I'll be using these variables all over here. So let us create our first container, that is container 1. And what you can do all over here, guys, that before creating the container, make sure that your Docker engine is up and running. So all over here, so since I have already created container 1 and container 2, so let me show you. It's going to show me error, but this is a command. So here docker run /d, then -- name, then here is my name of the container, and I'm using Nginx latest, okay, Alpine version. This is a systems image. It is going to create this container 1. Now if I try to enter it, since I've already have this container, now you can see I have got this container ID all over here. Similarly, you are going to get a container ID, but you will not get this error. Okay, so what I can do, I can remove this, okay, with a docker rm command, but I want to use the same variables. So for the same purpose, it's fine. Now, similarly, now let us create our Docker container 2. So we are going to get the ID for this also. So this we have already created. Pretty much fine. Now we have easily created this. Next thing is you need to install ping on your given containers. So what you can do, so if you haven't installed ping on your system, you can go all over here, apt get update y, and apt get install y iputils /ping, which is going to install your ping command. So I have already installed ping on my system. Now let's proceed with our next thing. In our next process, what we are going to do, we are going to go inside our login container. So all over here, we can type docker exec then it, and the name of the container is container1. Okay, same name which we have given, which is the login container. So container1, then /bin/bash. Okay, now we are inside our container1, and here if I type ping v, so you can see all over here that ping is not installed on this container. So directly go all over here, copy this command and first update it. So you can see all over here that it has started updating the packages. Now our next command would be try to install ping all over here. Now let us install the ping command, and you can see ping we have successfully installed all over here. Okay. So we have successfully installed ping on our container. Now let us look at what number of containers we have installed. So you can see all over here, we have container 2 and container 1 already created all over here. Now let us move ahead and try to do more configurations. Now let us try to inspect the network for the same. So I'll be using docker inspect command. So let's copy this. So you can see all over here, we have the IP address of 172.17.0.5. Just copy this, okay? And we are going to ping this from this terminal, okay? So from the container 1, we'll try to ping it up. So ping, then let's try again, ping. So I'm trying to ping 172.17.0.5. Just click enter, and you can see all over here, okay. So you can see all over here, when I'm trying to ping from this container 1 to product, so by default they have the bridge network configuration. And you can see we are getting the data from the container 2. So easily the communication is happening. This is a TCL handshake with ICMP protocol. And you can see the packets are being transferred. Now, what we are going to do next, we are going to create the next container. So let us go to the next terminal. And here, let us create our next. So, but here, we want to give a custom network configuration. So for the same, what I will do all over here, the same command, docker run d name. So I will just override this, the name of container 3. Okay. And here, what I'm trying to do is give a network called secure network configuration, which is a type called a bridge network only. And let us create this. Okay. Now you can see we have got the ID of this. So if I try to inspect this, okay, say docker inspect container 3. So we'll given an IP address all over here, and this is 172.18.0.3. Now if I try to communicate from this terminal, or stop this, okay, if I try to communicate with the container 3, we will see the request will be timeout. So you can see we are not getting any response all over here, because here we have created a different or a custom bridge network which has isolated the container for our payment system. Now we'll see all over here that the request has been timeout. So you can see all over here that we are not getting any information of communication from container 1 to container 3. It's completely isolated. Similarly, what I'll do, let us go to the container 2. So instead of 1, I'll type 2 all over here. And we are into container 2. Now if I try to communicate all over here, since ping is not installed, so let us install the ping first. Okay. Now after that, what you can do all over here, so you can just copy the same command and you can see ping is installed. Now let us try to, let's clear the screen first. Okay. Now when I'm trying to do the ping, so I have again copied this IP address. I'll be moving to my next terminal and so container 2 is trying to communicate with the container 3. So as I have told you earlier that container 2 and container 1 are in the same connected network, which is the bridge network, so that the communication is happening very easily. But container 3 and container 1 and 2 are isolated. So you can see from here also I'm not able to receive any information or any details all over here of the communication between them. So similarly for the same terminal 1, we can see still we are not getting any packets of data all over here. So in this way, we have completely secured one container from the another with the help of custom network that we have created, a bridge custom network, okay, with a parameter called network, in which I have given the name as secure network. So I'll show you the command again. So you can see all over here that we have created a custom container 3. Okay. So the command for giving the network, custom network was like -- network, then here equal to sign, then here I'm giving my custom network. It is a very easy tutorial, but it's very important for your understanding the concept of Docker networks. So with this simple example, I hope so you would have got a brief idea regarding what is Docker networks, why do we need it, what are custom networks, what are the security things that we need to take care of when we are creating Docker networks with the help of bridge network, and how we can create the custom bridge network. And also we studied regarding the host network, what it is. And I hope so you have enjoyed our today's video on Docker networks. Till then, keep learning and keep growing.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.